What's up? I'm Vin, and today I want to go through this ASVAB Arithmetic Reasoning Practice Test, and I'll leave a link to a copy of this test in the description below. So first up, we have a store offers a 20% discount on a sweater that was originally priced at $50, and then a sales tax of 5% is applied. We want to know what is the total cost of the sweater. So for this question here, if we're taking 20% off, one thing you could think of is dividing by 5, because 20% is the same thing as 20 out of 100. And if we reduce this fraction by dividing the top and bottom here by 20, we're going to get 1 over 5. So if I take $50 and I divide it by 5, that's going to tell me how much we're taking off. So we're doing $50 divided by 5, and that's $10. So how you want to think about this, imagine I have this circle here, and I break this up into 5 sections. So I'm just going to visualize the fractions here. So we have 1, 2, 3, and then 4, 5. And each of these are 10. So this is the total price of the sweater. The sweater is $50, okay? This is not my best artwork, but just imagine these are all equal parts. So if we take 20% off or 1/5 off, that tells us the remaining cost here of the sweater is $40, okay? Or you could just think that we're doing $50 and we're subtracting $10. So we're getting $10 off, and that tells us the cost of the sweater is $40. However, there is a 5% sales tax. So what I like to do from here is I just know that 10% of 40, a little trick is you take the number 40 and you move the decimal one place to the left. So I'm imagining 40.0 in my head, and I move the decimal one place to the left, and that tells me that 10% of 40 is $4. So if I want to find 5%, all I have to do is divide by 2. See, from here to here, I'm just dividing by 2. So if I do 4 divided by 2, I would get 2. So that's 5% of 40. So then the total here would be $40 plus $2. And this is going to work out here to $42. So that's the total cost here after the discount and with the tax. So choice A. Question 2, we have a recipe calls for 3/4 of a cup of sugar. And if a baker wants to make half of the recipe, how much sugar should they use? So for this question, we're starting out with 3/4 of a cup of sugar. And the baker is going to make half of the recipe. So we're going to take the 3/4 of a cup and we're going to take half of that, or we're going to multiply by 1 over 2. So now you just want to think here, you're multiplying these two fractions. You're doing 3 over 4 times 1 over 2. And to multiply two fractions, you're going to multiply the numerators together. So you're going to do 3 times 1. And then in the denominator, you're going to multiply these denominators. You're going to get 4 times 2. And this simplifies to 3 over 8. So this tells us that the baker is going to need 3/8 of a cup of sugar. And this is going to match up with choice C. Question 3, we have a car travels 150 miles using 5 gallons of gas. So 150 miles for 5 gallons of gas. And then at this rate, how many gallons of gas would be needed to travel 450 miles? So for this one, we could just set up the proportion. We're going to keep miles over gallons. So we're going to have miles in the second fraction here. So in this next ratio, and we have gallons in the denominator like this. Okay, so what we're looking for is how many gallons are needed to drive 450 miles. So for this one, if your mental math is really sharp, you could just look at this and say, oh, 150 times 3 would get me to 450. So then I'd have to do 5 times 3. So I'd multiply this by 3, and that would tell us that x is equal to 15. So we would have 15 gallons, choice B. If that didn't make sense, what you could do is you could cross multiply. So you could do 150 times x equals, and then you do 5 times 450. But then you'd have to start doing long multiplication like this. So 450 times 5, because remember, for the ASVAB, you don't get a calculator to do these sections. And you'd have to multiply this out. So it'd be 5 times 0, 5 times 5 is 25, carry the 2, and then 5 times 4 is 20, plus 2 is 22. So we would have 150x equals 2250, and then we'd have to divide both sides by 150. Okay, so this would take a little bit of time. We'd have x equals, and just know we have trailing zeros that we could cross off. So then we would be doing 225 divided by 15, and that would just be equal to 15. Okay, so this we could just work out like this. If you didn't have that memorized or able to do that in your head, what you could do is, see, this would create a lot more side work. You'd have to do 225 divided by 15, and you have to say something like 15 goes into 22 once. 1 times 15 is 15. You subtract, you get 7. You carry down the 5, and then 15 goes into 75 5 times. 5 times 15. I'm sorry, we're doing, 5 times 15 is 75. So we subtract, and this divides evenly. Okay, so this would be the long way to do the division. But if you just know that 15 times 15 is 225, then that would get you to x equals 15 even faster. But either way, we're getting choice B. Question 4, we have a ratio of red to blue marbles is 3 to 4. So the first thing I would like to do here is set up the fraction 3 over 4. And remember, red is associated with a 3. So I'm going to put red in the numerator, and we have blue in the denominator. It's very important that you know how to take a ratio and turn it into a fraction like this, because that's going to help you set up your proportion in a moment. And now what we're told is that there are 84 blue marbles. So I'm going to put 84 in the denominator because that's where the blue was written the first time in this first ratio. And we want to know how many red marbles are there. So we're going to put an X here in the numerator where the red marbles would go. So for this one, same idea. If you just know what we have to multiply by to get from 4 to 84, let's say you could just look at this and say, or you could even do the division, do 84 divided by 4, and this is going to work out to 21. You could see, oh, I'm going to do times 21. So then to find out how many red marbles, I would do 3 times 21 like this, and 21 times 3 is going to give us 63. Okay, so there will be 63 red marbles. Now, if that didn't make sense or that method, is just too tricky, what you could do is you could just cross multiply and you have 4 times x equals, and if we do 84 times 3, we're going to get 3 times 4 is 12. We carry the 1. 3 times 8 is 24, plus 1 is 25. We get 252. And then we just have to do the division here. So we divide both sides by 4. And then if we do the long division here, 252 divided by 4, 4 goes into 25 6 times. 6 times 4 is 24. Subtract, there's 1 left. We bring down the 2, and then 4 goes into 12 3 times. 3 times 4 is 12. Subtract, it goes in evenly. Okay, but either way, we're going to get x equals 63. So x equals 63. Choice A is our solution. Question 5, we have a tank could be filled by one pipe in 40 minutes and by another pipe in 60 minutes. And we want to know how long will it take to fill the tank if both pipes are used together. So for this question, it is very tempting to just say 40 plus 60 divided by 2. And finding the average of these two times would give us 50. But notice that 50 is not even an answer choice. And this is also just not the right approach. We have to be careful here. Let's say I call the first pipe pipe A. So then what we have is pipe A is going to fill one tank in 40 minutes. Okay, so I'm just going to write this stuff down. We have one tank being filled in 40 minutes using pipe A. Pipe B would fill one tank in 60 minutes. So the idea behind this question, or what I like to do, is get the times to match up. So I'm noticing here that if I were to count by 40s, I would get 40, 80, 120, and then I'd get 160 and so on. And if I count by 60s, I get 60, 120, 180, and so on. So notice that 120 is the first place that these two times match if I were to just find common multiples here, or in this case, the least common multiple. So what I'm going to do is I'm going to multiply both sides of this equation by 3. And this tells us that pipe A could fill 3 tanks in 120 minutes. And what we have over here is if I multiply both sides by 2, I have that pipe B could fill 2 tanks in 120 minutes. So now that the times match, we could start talking about what they could do together. So now I'm going to say together. Okay, if you just think about this logically, if pipe A fills 3 tanks in 120 minutes and pipe B fills 2 tanks in 120 minutes, if they work together, that means they're going to fill 5 tanks together. Okay, so 5 tanks in 120 minutes. Okay, so now if we want to know how fast can they fill up one tank together, we just divide both sides by 5. All right, so just think about that idea once again. 3 tanks, 120 minutes. Pipe B does 2 tanks in 120 minutes. So together, that's 5 tanks. So now we just work this out. This tells us that together, they could fill up 1 tank. And now we just do the division here. 120 divided by 5. 5 goes into 12 twice. 2 times 5 is 10. We subtract. And we have a difference of 2. We carry down the 0. And 5 goes into 20 4 times. And 4 times 5 is 20. When we subtract, we get 0. So this divides evenly. So 1 tank together in 24 minutes, and this is going to match up with choice A. Question 6, we have John earns $20 per hour and works 8 hours a day, and we want to know how much will he earn in 5 days. So for this question, just write out this rate over here. We have John earns $20 per hour, and he works 8 hours per day. So what this tells us, once we simplify here, notice hours over hours cancel, and we have 20 times 8 is 160. So this tells us that John earns $160 per day. And we want to know how much does John earn in 5 days. So if we just think about this here, $160 in 1 day, if we multiply the top and bottom of this fraction by 5, this is going to tell us how much John earns in 5 days. So now we're just going to do 160 times 5. And let's work this out over here. So we have 5 times 0 is 0. 5 times 6 is 30. We carry the 3. And then 5 times 1 is 5 plus 3 is 8. So this tells us that John earns $800 in 5 days. Okay, so we're just multiplying these values across here, and we're going to get choice B. Question 7, we have a bookstore sold 300 books in January, and then we have if they sold 20% more in February, how many books did they sell in February? So for this question, I want to show a different approach to this. I did show that 20% before you could just divide by 5, but let's say you want to practice multiplying by decimals. So 20% more, what I think here is I'm going to do 1 plus 20%. Okay, if it was 20% discount or 20% less, then I do 1 minus 20%. Okay, so this would be 20% less, then I would do 1 minus, but this is for 20% more. So now I'm just going to simplify this. 1 plus 20% is 1 plus 20 over 100, and this works out to 1 plus 0.20 if I turn 20 over 100 into a decimal. And then if I do 1 plus 0.20, that's going to give us 1.20. And this is what I'm going to multiply 300 by. So I'm going to do 300 times 1.2. Okay, I don't have to write that extra 0 at the end. That's just a placeholder. So I could just write 1.2 like this. So now this, what I'm going to do on the side here, instead of doing 300 times 1.2, I'm going to do 300 times 12. And then I'm going to pay the decimal back over here. So I do 2 times 0 is 0, 2 times 0 is still 0, 2 times 3 is 6, and now I put a placeholder, 1 times 0, I have 1 times 0, and I have 1 times 3. So this product here works out to 3,600. If you wanted to do this math in your head, just imagine that you're doing 12 times 3, and 12 times 3 is 36. So if I multiply by 300, I just write 36 with 2 extra zeros. So from here, I just want to think about this. If I'm doing 300 times 1.2, notice that's 1 decimal that I have to pay back. So this decimal over here in front of the 3,600, what I'm going to do with it is I'm going to move it 1 space to the left like this. So that's going to bring us to 360. Okay, so this tells us that 300 times 1.2 is 360, and that would tell us how many books were sold in February. Because remember, if you want to find 20% more of something, you could just multiply by 1 plus 20% like this. It is okay for you to do this instead. Like you can do 300 times 20%, just do 300 times 0.20 like this. And what you're going to do is you're going to get 60 when you multiply this. And then you could do 300 plus 60. However, I find that when you just multiply by 1 plus the percent, it adds the value on for you and finishes the question right away. So I prefer, once again, to do 1 plus when I'm doing 20% more, or I would do 1 minus 20% if I want to find 20% less. But in this case here, we're going to get choice C. Question 8, we have a wall is to be built using bricks that are 8 inches long and 2 inches high. And then we have if the wall is to be 16 feet long and 6 feet high, how many bricks will be needed? So for this question, let's just imagine the wall over here. So we have this wall, and the wall is 16 feet long by 6 feet high. And then we have each brick is 8 inches long. So the bricks over here are 8 inches long and they are 2 inches high. And we want to know, once again, how many bricks do we need to build this wall? So one thing we have to be careful of right away, though, is the units. Notice that the units for the bricks are in inches and the units for the wall are in feet. So we have to convert one of these into the other. So let's go ahead and convert the wall from feet to inches. So if we have the length of the wall is 16 feet, we can multiply by 12 if we're not being graded on our work. But if I want to be very technical here, technically I'm multiplying by 12 inches over 1 foot. Now, this is valid because 12 inches equals a foot. And when you divide equal things, you get 1. So I'm really just multiplying this by 1. So I'm not changing the value of 16 feet. I'm just changing its representation. And now notice mathematically here, we have feet over feet canceling. And now we just have to do 16 times 12. So 16 times 12, I'll just do this off to the side, is going to give us, we're going to have 6 times 2 is 12. So we have 2, we carry the 1. 2 times 1 plus 2 is 3. And then we put a placeholder, 1 times 6, 1 times 1. So this works out to 192. So we have 192 inches. That is the length of the wall. So I'll just write that over here, 192 inches. And now the height of the wall, we could find by doing 6 feet times 12 inches over 1 foot. So we're just going to work this part out here. Feet over feet cancel, and 6 times 12 is 72. So the height of the wall is 72 inches. So now we're ready to divide. So if these bricks are 8 inches long, we're basically trying to see here how many bricks could we fit going all the way across. So we could do 192 inches and divide that by 8 inches. So we just do the long division over here. So we have 192 divided by 8. 8 goes into 19 twice. 2 times 8 is 16. We have a remainder of 3. We carry down the 2, and then 8 goes into 32 4 times, and we subtract 32, and we get a remainder of 0. Okay, so that tells us we could fit 24 bricks going across. And now how many bricks could we fit going up? This time around, we have to take 72 inches and divide by the height of the bricks are 2 inches. So when we divide here, we're going to get 36. So we're going to multiply 24 times 36 because once again, we could stack 36 bricks going up since they are only 2 inches high. So now we just work this out. So we'll just give ourselves a little space. We have 6 times 4 is 24. We carry the 2. And then we have 6 times 2 is 12 plus 2 is 14. So now we can get rid of the 2 that we carried so we can move to the next row. And we have 3 times 4 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. And now we just add the stuff up here. We have 4. 4 plus 2 is 6. 1 plus 7 is 8. And that tells us we're going to need 864 bricks to build this wall. Now, just one quick thing to mention here. If this concept didn't make sense, what we basically just counted was that there were 24 bricks going across like this. But we also have to account for how many bricks we could stack up this way. So each column here is going to have 36 like this. So that's why it's kind of like finding the area of a rectangle. What we're basically doing is just counting how many of these individual bricks we have. So we're just doing the length times the width. And once again, we could fit 24 bricks going across, and we could fit 36 bricks. So let me just make that a little bit neater. We could fit 36 bricks going up. So that's why we're multiplying here. It's kind of like we're just finding the area in a way, but we're doing 24 times 36, and choice D is our correct answer. Question 9, we have if a school purchases computers at a cost of $500 each and gets a bulk discount of 10% for purchasing more than 20 computers, how much will 25 computers cost in total? So for this question, the first thing I would do is find the cost of 25 computers before the discount. So I would take the $500 and I would multiply it by 25. So let's go ahead and do that. So what we're going to have here, and if you want to know a little mental math trick here, if you want to do this without long multiplication, just think of what is 25 times 5. And for this, if you just know that this is 125, then you know at the end you're going to get 12500 since a 500 has 2 zeros at the end. So if I just add 2 zeros here, I would have to add 2 zeros here. So I know that we're going to get this at the end. But now let's go ahead and do the long multiplication anyway. We have 5 times 0 is 0. 5 times 0 is 0. We have 5 times 5 is 25. And now we put a placeholder here. And then we have 2 times 0. We have 2 times 0. And we have 2 times 5 is 10. And now when we add everything up, 0 plus 0 is 0. 0 plus 0 is still 0. And then we have 5 plus 0, 2 plus 0, and 1 just carries down like this. So this is the cost before the discount. But we have to be careful here. Choice B is a very dangerous bear trap. We have to make sure that we read this very carefully and we account for the bulk discount of 10%. So now what we're going to do is we're going to take 10% of this and subtract it off. Now, a nice little trick for this is when you have a number like 12,500, what you could do is you just take the decimal and move it one place to the left when you want to find 10%. So I know that 10% of 12,500, that this is equal to 1,250. Okay, so this is what we're going to subtract from 12,500, and that's going to get us our final answer. So we're going to do minus 1,250, that's the 10% off. And now we're doing 0 minus 0. And then to do 0 minus 5, we're going to have to borrow from this column here. So we're going to borrow and make this a 4, and this becomes 10 minus 5 is 5. We have 4 minus 2 is 2, and 2 minus 1 is 1. And now we just carry down this one here. So the final answer is $11,250, choice A. Question 10, we have a bag contains oranges and the total weight of the oranges is 4 pounds, 8 ounces. If one orange is 8 ounces, how many oranges are there in the bag? And we're going to assume the weight of the bag itself is negligible, which means the bag is not contributing to the weight 4 pounds, 8 ounces. So for this question, we have to know that 1 pound, so we have 1 pound is equal to 16 ounces. So if we want to know how much 4 pounds is in ounces, I'm just going to do times 4 on both sides. And this is going to tell us here that 4 pounds, so 4 lbs, so 4 pounds is equal to 64 ounces. Okay, I'm just doing 16 times 4 is 64. So what we could say is the total weight is 64 ounces, and 8 ounces means we're going to add 8 ounces. So in total, the total weight of the bag of oranges is going to be 72 ounces. So now we have to account for this part, that one orange weighs 8 ounces. So now we just do 72 ounces divided by 8 ounces. And that tells us that there are going to be 9 oranges in this bag. Choice D is our answer. Question 11, we have a construction worker needs to distribute 120 bricks evenly among 4 wheelbarrows. And we want to know how many bricks does each wheelbarrow get. So for this one, the $1 million phrase is that the bricks are being distributed evenly. So that means we could just divide here. We're going to do 120 divided by 4. And this tells us that each wheelbarrow is going to get 30 bricks. Okay, so we're just dividing here the total amount of bricks amongst the 4 wheelbarrows. So each one is going to get 30. Question 12, if a runner completes 3 laps of a 400-meter track in 4 minutes, what is the runner's average speed in meters per minute? So for this one here, what we have to be mindful of is that the runner is completing 3 laps. So 3 laps, we're going to do 3 times 400 meters. Because once again, they're going 400 meters 3 times. So we're going to just multiply by 3. And this tells us that the runner is going 1,200 meters. But they're telling us here that it takes the runner 4 minutes to do 3 laps of 400 meters. So what we're going to do next is we're just going to take the 1,200 meters and we're going to divide it by 4 minutes. And notice that the units here are meters per minute, which matches all of the answer choices. So now we just have to divide. 1,200 divided by 4 is 300. So the runner's pace here is 300 meters per minute. Now, one thing here, just in case this mental math didn't make sense, what you're doing essentially is you're just thinking about what is 12 divided by 4. And 12 divided by 4 is equal to 3. So if I just keep adding zeros here, like let's say I say 120 divided by 4 and I'll write it as a fraction, this would be 30. So 1,200 divided by 4 would be a 3 with 2 zeros. We would have 300 meters per minute. And this would match up with choice B. Question 13, we have a rectangular garden measuring 20 feet by 30 feet, and it's going to be covered by mulch. If 1 bag of mulch covers 5 square feet, how many bags are needed to cover the garden? So for this question, the first thing we could do is just draw out a rectangle, and this is going to represent the garden itself. So we have the longer side is 30 feet, and the shorter side is 20 feet. And what we're told is that 1 bag of mulch, I'll write that over here, 1 bag of mulch covers 5 square feet. So I'm just going to say 1 bag equals 5 square feet like this. So I'm writing feet to the second power like that. And when we're talking about square feet, that means we should be focusing on the area of the garden. And the area of a rectangle is length times width. Okay, so I'm just going to multiply these two values together first to get the area of the garden. So we're going to do 30 feet times 20 feet. Now, the work you show doesn't matter when it's multiple choice, but I'm just going to show this as precise as I can. So what I'm going to do first is 30 times 20 is 600. And then feet times feet, I'm going to write feet to the second power, but this really means square feet. So now think about what they told us over here. They said 1 bag covers 5 square feet, and we have this many square feet of area in the whole garden. So what we're going to do is we're going to divide 600 square feet. Let me just make that a little bit neater. So we're going to do 600 square feet, and we're going to divide that by 5 square feet. And that's going to tell us how many bags we need. So we divide here, and now I'll just do the long division on the side since we don't get a calculator. So 600 divided by 5 goes into 60. Or first I could just do 5 goes into 6. If you know 5 goes into 60 12 times, then great. Otherwise, say 5 goes into 6 once. 1 times 5 is 5, and you subtract. You get a remainder of 1. You bring down a 0. 5 goes into 10 twice. 2 times 5 is 10. We subtract. We get a remainder of 0, and we could bring down another 0 like this. But 0, 0, just say we're dividing into 0. And when we do 5 goes into 0, or 0 divided by 5, we get 0. 0 times 5 is 0, so we get no remainder here. So this is going to divide evenly into each other 120 times like this. So this tells us that we would need 120 bags of mulch to cover this entire garden. Question 14, we have a factory produces 250 units of a product each day. If the factory operates 7 days a week, how many units does it produce in 4 weeks? So for this question, if you just know to multiply all these numbers together, then great. Otherwise, just think about it like this. We have this rate over here, 250 units per day. That is the rate we're starting with. So the factory makes 250 units for 1 day like this. And now we know that the factory operates 7 days a week. So what we could say over here is, let's have 7 days in the denominator. And I'll just write 7 day like this so that the units match. And we want to know how many units are going to go here. Well, to get from 1 to 7, we would just do times 7. So to get from here to here, we're going to do times 7 again. So I just have to do 250 times 7 off to the side. So 250 times 7, we have 7 times 0 is 0. 7 times 5 is 35, and we carry the 3. And then 7 times 2 is 14, plus 3 is 17. So we have 1,750 units going up top like this. So that tells us that the factory makes 1,750 units every week because 7 days is equal to 1 week. So now we want to know how many units does the factory make in 4 weeks. So what we're going to write over here is we have 4 weeks going in the denominator. And once again, I'll just make these match. I'm just going to say 4 week. And now we have units going in the numerator. So to get from 1 to 4, we would just do times 4. So then to get from here to here, we're also going to do times 4. And now off to the side, I'm just going to do 1,750 times 4. And for this part, we have 4 times 0 is 0. 4 times 5 is 20, so we have a 0, we carry the 2. 4 times 7 is 28, plus 2 is 30, so we have a 0 and we carry a 3. And then 4 times 1 is 4, plus 3 is 7. So 7,000 units are going to be produced in 4 weeks. Choice C is our answer. Question 15, we have a book has 480 pages. If a student reads 1/4 of the book each day, how many pages does the student read in a day? So for this question, all we're going to do is take 480 and we're going to take 1/4 of it. So we're going to multiply by 1/4. And just know that when you multiply by 1/4, this is the same thing as dividing by 4. So we're going to do 480 divided by 4. And we have 4 goes into 4 one time. 1 times 4 is 4. So this subtracts here to make 0. We carry down the 8. 4 goes into 8 twice. And 2 times 4 is 8. So this goes in evenly with the remainder of 0. And then we have 4 goes into 0 0 times. 0 times 4 is 0. So when we subtract 0 here, we have no remainder. So this tells us that the student reads 120 pages per day. Choice A is our answer. Question 16, a group of friends share the cost of a $60 gift. If each friend contributes $5, how many friends are in the group? So for this question, we have a $60 gift and each friend is contributing $5. So if we just do $60 divided by $5, notice the units cancel out. We're doing 60 divided by 5, which is 12. So there are 12 friends in the group. Choice C is our answer. Question 17, we have a rectangular room measures 15 feet in length and 10 feet in width. What is the area of the room in square feet? So for this question, just imagine we have this room over here, and this room is in the shape of a rectangle. The length of the room is 15 feet, and the width of the room is 10 feet. So to find the area of a rectangle, we just do length times width. So we just have to plug into the formula now. We have the area of the room is 15 feet times 10 feet. Okay, so we're just going to plug into the formula and multiply. So the area of the room is 15 times 10 is 150, and then feet times feet is feet to the second power or square feet. So this is going to match up with choice A. Just know that you could write feet to the second power or square feet, or you could actually write out like this, 150 square feet. And this would still, once again, match up with choice A. Question 18, we have if a customer pays $18 for 2 pounds of coffee, how much does the coffee cost per ounce? So for this question, we're starting out with this right here. We have the coffee is $18 for 2 pounds of coffee. So what we could do here is we could divide. 18 divided by 2 is 9. And this tells us that the coffee costs $9 for 1 pound of coffee. And now from here, we should know that 1 pound is equal to 16 ounces because our goal here is to find the rate in cost per ounce. So what we're going to do is we're going to change this here from 1 pound to 16 ounces. So we could say the coffee is $9 for 16 ounces of coffee. And then from here, what we want to do is find the unit rate. So we're going to do 9 divided by 16. But notice that 9 is smaller or less than 16. So when we do the division over here, we just have to be careful. We're doing 9 divided by 16. And I'm going to put a 9.0 like this because 16 goes into 9 0 times. And then I put a decimal right above. But then 16 goes into 90 5 times. And 5 times 16 is 80. So when I subtract 80, I'm going to have a remainder of 10. And now I put an extra 0 and I carry it down. And we could say 16 goes into 100 6 times. And if you do 6 times 16, you're going to get 96. So when you subtract, you have a remainder of 4. We put another 0. And we carry down here, 16 goes into 40 twice. 2 times 16 is 32. And when you subtract, you get a remainder of 8. And now we put another 0 here to bring down. And this, we have 16 goes into 80 5 times. But remember, we're talking about money here. So we only have to round to the hundredths place, 2 decimal places to the right. So we just look at the 6 over here, and we look to the right as a 2. So we could round this down to 56 cents. So we're going to say that the coffee cost 56 cents for 1 ounce. Okay, so 56 cents per ounce is going to match up with choice A. Question 19, we have an employee gets paid every 2 weeks and earns $1,200 per paycheck. How much does the employee earn in a year? So for this question here, we have to know that there's 52 weeks in a year. Okay, so 1 year is equal to 52 weeks. So if we think about this, the employee gets paid once every 2 weeks. So it's one paycheck. So one paycheck every 2 weeks. Okay, so this is 2 weeks. 2 weeks goes by, that equals a paycheck. So here, think about how do you get from 2 weeks to 52 weeks? You would just multiply by 26. Okay, if that's not clear, like where I'm getting that number from, the math that I'm doing in my head is I'm taking 52 and I'm dividing it by 2, because if the person gets paid every 2 weeks and there's 52 weeks in a year, we divide by 2 to make groups of 2 weeks, and there's 26 groups of 2 weeks. Okay, so that's 26 paychecks. So this person's getting paid 26 times in the 52-week year. Okay, so now we just have to think here, if each paycheck is $1,200 and they get 26 paychecks, we're just going to multiply. We're going to do 1,200 times 26 and work this out. So you got 6 times 0 is 0, 6 times 0 is 0, 6 times 2 is 12, we carry the 1, and then we have 6 times 1 plus 1 is 7. And now we put a placeholder here, and we can get rid of this one. 2 times 0 is 0, 2 times 0 is still 0, 2 times 2 is 4, and 2 times 1 is 2. And now we just add everything up. We'll make that a little bit neater. And we've got 0 plus 0, and then we have 2 plus 0 is 2, 7 plus 4 is 1. Oh, I'm sorry, 11, but we carry the 1 up here. And then 1 plus 2 is 3. So this person is going to make $31,200 per year if we total all of their paychecks. And this is going to match up with choice C. Question 20, we have a car's odometer shows this many miles before a trip and this many miles after a trip. And we want to know how many miles was the trip. Okay, so we're going to subtract how many miles there were after the trip and the amount of miles before the trip. Okay, so we want to know what is the difference here. So we have 25,653 and we are subtracting 25,362. So here we're going to do 3 minus 2 is 1. 5 minus 6 we can't do because 5 minus 6 goes into the negatives. So we're going to borrow from the next column here and turn this into a 5. And now we do 15 minus 6 is 9. 5 minus 3 is 2. And then notice 5 minus 5 is 0. 2 minus 2 is 0. So this is the difference that we're left with. So the trip was 291 miles, and that matches up with choice A. Question 21, we have a square playground has a perimeter of 64 meters, and we want to know what is the length of each side of the playground. So for this question here, I'm just imagining a square, and we're told the perimeter of the square is 64 meters. Okay, so we just have to know that the perimeter of a square, if we call each side x, so I'm just going to put an x all around. The perimeter of a square, or the perimeter of any shape, you just add up the distance all the way around. So here I could do x, and then plus another 2x's like this, and this would equal 4x. So what we have is, we could say 4x is equal to the perimeter is 64 meters. But I'm just going to write 64, and we'll worry about the units at the end. And now just divide both sides by 4. And this tells you the length of each side. So we have 4 goes into 6 once with the remainder of 2. This is a little shortcut to long division. And then we have 4 goes into 24 6 times. So each side is 16 meters long. And if we want to check our answer to this, so let's just say we want to make sure that this is definitely the answer. What we could do is we could plug back in here and see that if we add up, let's say I want to do this with a sum here. If I add up these 4 values, 6 plus itself 4 times is 24. We carry the 2, and then 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6. And notice that we get our perimeter of 64 meters. So each side is 16 meters. Question 22, we have a technician charges $50 per hour and spends 3 hours and 30 minutes on a job. What is the total charge here? So for this question, what we should do is we're going to set up a proportion. We know the person charges $50 per hour, okay? But this is for 1 hour. And we want to know how much money they're going to charge for 3 hours and 30 minutes. So the first thing I would do is turn this all into hours. So we should know that a 30-minute time period is the same thing as half an hour, okay? So this is the same thing as half an hour. So if the person is working 3 hours and 30 minutes, that means they're going 3 hours plus half of an hour. So this is equal to 3.5, or I could just say 3.5 hours. So when we set up the proportion over here, we're just going to set the denominator equal to 3.5 hours like this. And this tells us now we're looking for how much money they make. So we're going to say X dollars. So now I'm going to cross multiply, but I'm only going to multiply the values together, not the units. So X times 1 is X. And then I'm doing 50 times 3.5. So we have 50 times 3.5. So for this one here, on this side, I'm just going to multiply 35 times 50. And I'll worry about the decimal place at the end. So we could do 0 times 5 is 0. 0 times 3 is 0. We put a placeholder, and then we have 5 times 5 is 25. We carry the 2. 5 times 3 is 15, plus 2 is 17. Okay, so this product here works out to 1,750. But let's think about this. This was 50 times 35. So if I'm doing 50 times 3.5, I'm imagining the same thing, but notice that in this case, I have one decimal place that I have to pay back. So I'm going to take the decimal from 1,750 and I'm going to move it 1 unit to the left to make 175. So X is equal to 175. And this tells us that the technician is going to charge $175. And this is going to match up with choice B. Question 23, we have a train travels 240 miles in 4 hours. And then we have, at the same rate, how far will the train travel in 10 hours? So for this question, let's start out with this rate here. We have 240 miles in 4 hours. Okay, so 240 miles for 4 hours of the train moving here. And if we divide here, 240 divided by 4 is equal to 60. Okay, what I'm imagining here, I'm just doing, in my head, I'm doing 24 divided by 4. So 24 divided by 4 is equal to 6. So it's kind of the same idea, but I'm just putting an extra 0 at the end. So the train goes 240 miles in 4 hours, which is equivalent to 60 miles per hour. Okay, but instead of writing mph for miles per hour like this, I want to write it as a fraction, just like we did over here. So this is equal to 60 miles per hour. But we want to know how far does the train go in 10 hours. So from here, I could have just multiplied this fraction on top and bottom by 2.5. But I find it much easier to multiply by 10, because when you multiply any number by 10, like in this case 60, 60 times 10 is equal to 600. Okay, so that's why I reduced it first, because once again, multiplying by 10 is much easier than multiplying by 2.5, which would, if we did 4 times 2.5, this is equal to 10. Okay, so that's where I'm getting that 2.5 from. I would have to multiply the top and bottom by 2.5. But reducing first, now I could just multiply the top and bottom by 10 over 10. And this tells us that the train would go 600 miles in 10 hours. Okay, so you see I'm doing 10 times 60 is 600, and the units on top are miles, and then 1 times 10 is 10, and the units on bottom are hours. So how far does the train travel in 10 hours if they're going at the same rate? That's going to be 600 miles, choice A. Question 24, we have a store is having a sale where every item is 25% off. If a shirt originally cost $28, what is the amount of the discount? So for this question, we just want to know what the discount is. We don't want to know what the final cost of the shirt is. So if we're starting out with a shirt that's $28 and we want to take 25% off, remember 25% is the same thing as 25 out of 100. And if we reduce this, divide the top and bottom by 25, this fraction reduces to 1 over 4. So what we could do to make this a lot easier is, instead of multiplying by 25%, because you could do this, you could do 28 times 0.25 and work out this product, but that takes a lot of time. Instead, we could just multiply by 1/4. And when you multiply by 1/4, that's the same thing as dividing by 4. Okay, so this, just think of this as 28 over 1. I would multiply these numerators to get $28 on top, divided by 1 times 4 is 4. And $28 divided by 4 is just going to give us $7, which is the amount of the discount. Question 25, a family drives 150 miles to a vacation spot and then drives another 75 miles to a relative's house. If the total trip took 5 hours, what was their average speed? So for this question here, when you're trying to find speed, what you should be thinking about is distance traveled over time. Okay, so the amount of distance they covered and the total time it took for them to cover that distance. So we just have to be careful here. We have to think about this family trip. The family drove 150 miles first to their vacation spot, but then they drove another 75 miles to a relative's house. Okay, so in total, we have to find how much distance did they cover in this trip. They went 150 plus 75. So this adds up here. We just do 0 plus 5. 5 plus 7 is 12. We carry the 1. the family traveled 225 miles in total. Okay, so I'm doing 225 miles, and we were told that the trip took a total of 5 hours. So now we just have to reduce this to find the average speed that they were traveling. So here we're going to do 225 divided by 5. So we could set up the long division on the side. We're going to do 225 divided by 5, and we have 5 goes into 22 4 times. 4 times 5 is 20. We subtract that. We have a remainder of 2. We bring down the 5, and then 5 goes into 25 evenly 5 times. 5 times 5 is 25. We subtract, and we have no remainder here. So this tells us that the average speed was 45 miles per hour, and this is going to match up with choice C. Question 26. If 8 ounces of spaghetti cost $1.20, what is the cost for 2 pounds of spaghetti? So for this question, we could start out with this rate here, that spaghetti cost $1.20 for 8 ounces of spaghetti. So we're starting with this rate here, and one way to do this is we can convert 2 pounds into ounces, and then we could use that number to set up another ratio in terms of dollars and ounces, and then we could solve for the missing amount. So 2 pounds we could find in ounces by starting with 1 pound equals 16 ounces. And then from here, we could just multiply both sides by 2. And this tells us that 2 pounds is equal to 32 ounces. And then from here, if we're looking for the cost of 2 pounds, that's the same thing as finding the cost of 32 ounces. And then to get from 8 to 32, we just do times 4. So then to find the missing value in the numerator, just do times 4. And if we do $1.20 times 4, that's going to give us $4.80. The math that I'm doing in my head to be able to do that quickly is I'm just thinking of, instead of doing $1.20 times 4, I'm doing 12 times 4. And I know that 12 times 4 is 48. So I'm just moving the decimal accordingly. Okay, $1.20 times 4, it resembles 48, but it would be $4.80. Okay, so that's the mystery amount here. Now, another way to do this is to start off with 1 pound is equal to 16 ounces. And this time around, we could divide both sides by 2. And if we divide both sides by 2, 1 divided by 2 is 1/2. So that tells us that half of a pound, or 0.5 pounds, is equal to 8 ounces. And notice here that if we're starting out with 8 ounces of spaghetti cost $1.20, we could say that $1.20 will not only buy you 8 ounces of spaghetti, it'll buy you in other units half a pound of spaghetti. Okay, so this means the same thing as what we're starting with over here. And then when we're looking for how much 2 pounds of spaghetti cost, now we could just think, how do we get from 0.5 to 2? We're just going to multiply both sides by 4. So once again, if we do times 4, this tells us that the price of 2 pounds of spaghetti is going to be $4.80. But either way, we're getting choice C. Question 27. A runner jogs around a rectangular park that is 100 meters long and 50 meters wide. The runner starts at one corner and jogs to the opposite corner diagonally across the park. And we need to calculate the semi-perimeter of the path the runner takes. So this park we could model with a rectangle. Okay, they told us that the park is rectangular, which means it's in the shape of a rectangle. And the park is 100 meters long and 50 meters wide. Okay, we know that in a rectangle, opposite sides are equal in measure. So I could say that this side over here is 100 meters, and I could say this side over here is 50 meters. But this runner is starting at one corner and running to the opposite corner diagonally across the park like this. Now remember, the runner is running around the park, okay? It's not going through like this along the hypotenuse of this right triangle. If I were to turn this into a right triangle like this, the runner is not running through the park, the runner is going around the park. So all we have to do here to find the semi-perimeter is we just have to add up here. We're going to say the semi-perimeter, we're just going to call S, is equal to 100 meters plus 50 meters. And this is going to work out to 150 meters. Question 28, a movie theater charges $11 for adults, $8 for children. And then we have, if a group of 3 adults and 4 children attend a movie, and the group also buys 3 bags of popcorn for $6 each, what is the total cost for the group? So for this question here, let's just tally up the cost of everything for the adults, for the children, and then for the popcorn. Okay, so these are 3 things we have to consider here. Now, there are 3 adults in the group, and the adult tickets are $11 each. So if we do $11 times 3, this tells us that the adult tickets are going to cost $33. And then next we have the kid tickets are $8 each. And there are 4 kids in the group, so we just multiply by 4, and this is going to work out to 32. And then we have the popcorn. The popcorn costs $6 each, and this group buys 3 bags. So this is going to run up the bill to $18 for popcorn. So now what is the total cost? We're just going to add these numbers together. Okay, so let's just add all of this up. So we're doing 33 plus 32 plus 18. And now we add this up. Notice we have a group of 10. So we have 10 plus 3 is 13. We carry the 1. And then we have 6 plus 1 plus 1 is 8. So the total bill is going to be $83. And this is going to match up with choice B. Question 29, a company has 4 machines that produce 300 widgets each per hour. If the company operates these machines for 8 hours, how many widgets are produced in total? So for this question here, we have the 4 machines. So let's just imagine we have 4 machines over here. So these just represent the machines. And each machine produces 300 widgets per hour. Okay, so that's 300, and the units are widgets per hour. So widgets per hour, I'll just label like this. So let's think about the next step here. So what we're told is that the machines are running for 8 hours. So let's just think about how many widgets per hour do all of the machines produce together. Okay, so the total rate I'm just going to find here would be 1200 because I'm doing 300 times 4. Okay, 300 times 4 is 1200. So that tells us the total rate is that all of the machines produce 1200 widgets per hour if they're all working at the same time together. Okay, so if the machines are working for 8 hours, we could set up the following proportion. We could say 1200 widgets for 1 hour is equal to blank widgets for 8 hours. So to get from here to here, we just do times 8. So then to get the missing value in the numerator, we're just going to multiply 1200 times 8. Now for this question, the shortcut, I would just imagine 12 times 8 in my head. And 12 times 8 is 96. So if I do 1200 times 8, that's 96 with 2 zeros. So that would be 9,600 widgets. If you want to do the long multiplication, you just have to do 1200 times 8. And you got 8 times 0, 8 times 0. 8 times 2 is 16, carry the 1. And then 8 times 1 plus 1 is 9. So either way, we're getting 9,600 widgets. And that's going to match up with choice B. Question 30, our last question. We have a rectangular garden measures 50 feet in length and 20 feet in width. A path 2 feet wide runs around the inside perimeter of the garden. What is the area of the path? So for this question, the first thing we should do is just draw out a rectangle to model the entire garden here. So there's our rectangular garden. It's 50 feet long and it is 20 feet wide. And then we have that the path is 2 feet wide and it runs around the inside perimeter. So I'm just imagining something like this. So it's just going around the perimeter like this on the inside. So a path to walk along here. Now, one thing to be mindful of is, once again, the distance all the way across this way and this way is 2 feet. So I could just draw in these extra lines here and just say, once again, the labels for all of these distances are 2 feet. So this little piece over here is 2 feet. We have that this piece over here is 2 feet. The distance over here, once again, is 2 feet. So this is just all the way around. These little distances are 2 feet. And now what we want to do is we want to find the area of just the path. So that's what we're looking for, is what is the area of this section here. Okay, so that's what we're looking for. Now, there's a few different ways we could do this. But one way that we could do this is we could find the total area of the entire rectangle. So we could do the total area minus the shaded area. So I'm just going to call this over here the shaded area on the inside, okay? Not including the walking path. So the area of the path, so the area of the path we could say is equal to the total area and then minus the shaded area. Okay, so that's the area that I just shaded in yellow. Okay, so minus the shaded area. So first let's find what is the total area. Well, the entire length was 50 feet and the entire width was 20 feet. So the formula for the area of a rectangle is length times width. So the total area we could say is equal to 50 feet times 20 feet. And this works out to 1,000 square feet. Okay, I'm just doing 5 times 2 is 10, and then I have 2 extra zeros to tack on. So 1,000 square feet, that is the total area. So we have the area of the path is equal to, and now we have 1,000 square feet, and we just have to subtract what is the area of the shaded area. Well, one thing to be mindful of here is that to find the dimensions of this rectangle on the inside, we're just going to have to consider the 2-foot width of the path. Okay, so let's just think about how does that affect the dimensions of this inside rectangle. Well, notice here that going across, this entire distance going across from here to here is 50. So if I chop off 2 feet on the left and 2 feet on the right, I'm subtracting 4 feet in total from 50. And that tells me that the distance across from here to here is 46 feet. Because if you just think about this, if I do 2 plus 46 plus 2, that's going to give me the 50 feet, which represents the entire length of this rectangular garden. And now I do something similar going this way. Going this way, the width is 20 feet. But once again, if I chop off 2 feet and I chop off 2 feet on the bottom here, top and bottom, I'm doing 20 minus 4 is equal to 16. Okay, so the width of the inside shaded rectangle is 16 feet. Once again, to really convince yourself of this, just know that this distance over here is 2. The distance underneath here is 2. So if I do 2 plus 16 plus 2, that gives me the entire 20. So now to find the area of the shaded region here, I'm going to find the shaded area. And for this, I just have to do a little bit of multiplication. Okay, I'm going to have to do 46 times 16. So we'll just work that out over here. So we have 46 times 16. And this is going to give us, we have 6 times 6 is 36. We carry the 3. 6 times 4 is 24, plus 3 is 27. We put a placeholder, and then we have 1 times 6, 1 times 4. We work this out, and we have 7 plus 6 is 13, carry the 1. So this gives us 736. So that is the shaded area. And now what we could do is we could subtract this from 1,000, and that's going to tell us the area of just the walking path. So we'll do that subtraction over here. We have 1,000. And we're subtracting 736. Now for this part here, I can't do 0 minus 6, and I can't borrow from a 0. I have to borrow from this. So when I borrow from here and I make this a 0, this becomes a 10, and then I have to borrow from this and make it a 9. This becomes a 10, and then I have to borrow from this one, it becomes a 9, and this becomes a 1. So now I have 10 minus 6 is 4, 9 minus 3 is 6, 9 minus 7 is 2. So the difference here is going to be 264 square feet, and this once again represents the area of the path, and this is going to match up with choice D. Now, one more thing before we close this out, there is another way to do this question. We could find the area of all of these shapes individually, add them up, and that would tell us the area of the walking path. So what I could do is use the formula area equals length times width, and I could find the area of all of these shapes here. So this one here is a 2 by 2. So if I do 2 times 2, that's going to give me 4 square feet. But I'll leave the units out for now. I'm just going to write 4. And now this piece over here is 46 units this way, 46 feet by 2 feet. And if I did 46 times 2, that's 92. So this piece over here is 92 square feet. And then I have 2 times 2 is 4. So this area is 4 square feet. 16 times 2 is 32 square feet. Over here, I have 2 times 2 is 4. So that's 4 square feet. And then I have 46 times 2 is 92. So this area of this rectangular piece is 92 square feet. And then we have 2 times 2 is 4. So this is 4 square feet. And then finally, this piece is 16 times 2. So if you do 16 feet times 2 feet, we get 32 square feet. And now all we would have to do is add all of this stuff up. So we have 92 plus 92. We have 32 plus 32. And then we also have in the corners here, we have 4, 4, 4, and 4, which is 16. So now I just add all of this stuff up. 2 plus 2 plus 2 plus 2 is 8. 8 plus 6 is 14. We carry the 1. And then I have 10 plus 9 is 19. Plus 3 is 22. Plus 3 is 25. And 25 plus 1 is 26. And notice that this gives us 264 square feet. Either way, we get the same answer.